Hello, darling children. We're going to talk today about spheres. Are you so excited? Yes? Okay, good. So you should be taking notes right now. Copper and I are going to teach you all about the surface area and the volume of spheres. Isn't that right, Copper? He says yes. But before we do, you should probably put in your notebook or your planner, our celebration of learning is going to be on May 14th and 15th for my grade A babies. So write that down. Thank you. Wonderful. How exciting. So you will be getting the review for Unit 11 next class. But I will post it on Google Classroom, so if you want to start this weekend, it'll be up. Okie doke. All right. So this one is probably the easiest. Got some weird fractions for the formulas, but spheres are quite simple because there's only one variable involved, and that is the radius. So go ahead and draw a circle. This is how you draw a sphere. You draw a circle, and then you just draw a little boop right there, and then behind it you have a little boop, 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 boop right there. Sorry. Oh, that messed up. Wait, one more time, and go. Okay, good enough to where, it gives us this nice three-dimensional look. So let's talk about the formulas. Surface area, there's only one surface, right? So there's actually no lateral area formula for spheres. It's just all one total surface. So it's 4 pi r squared. 4 pi r squared. Got that? Okay. And then volume, how much space does the sphere take up? Very similar, but it is 4 pi r cubed. Okay. Probably the most common mistake is forgetting to cube the radius instead of squaring it. Okay, so you're multiplying that number by itself 3 times instead of 2, or with your calculator, it's easiest to just do the little caret button and raise it to the 3rd power. So 4 pi r cubed divided by 3. So kind of have this gross fraction there, but it's really not too bad. So these are your formulas that you'll be given for surface area and volume of a sphere. Let's do a few examples, make sure we understand that. Okay, first one's really super duper easy, but I'm going to do it anyway. So, find surface area and volume. Oh, where did that come from? Find the surface area and volume of a sphere with radius equal to 5 centimeters. You have 5 centimeters right here. Okay, so the surface area, very simple. It's going to be 4 pi and then 5 squared. 5 squared is 25. So you have 4 pi times 25, and 4 times 25 is 100. So surface area of this sphere is 100 centimeters cubed. Oh, sorry, 100 pi. Very different. Okay. You may have noticed already on your homework, for anytime you're dealing with pi, it'll say either to round to the nearest decimal or to leave your answer as an exact answer in terms of pi. So just read the question to know whether to write in pi, which is what I always prefer, and that'll be like on your quizzes. You're going to leave it in terms of pi. However, if it did want you to write the decimal for this, you would multiply that by pi in your calculator. So that'd be pi times 100, which would be approximately 314 point, I'll just round it to 2. So it just depends on how the question's worded. So that is surface area there. Cool. Okay, and don't forget the pi, or else your answer's wrong. Right, Copper? He says right. He's a good boy. Okay, so for volume, we're going to be doing 4 pi times 5 cubed, and then divide that by 3. So really, you can type all this in your calculator except pi, but I'm going to break it down for you so you can see what we're doing. So 5 to the 3rd power is 125. And then I always like to do the numerator first, so we're going to keep breaking that down. 125 times 4 is 500 pi, and then 3 on the bottom. So since 3 does not divide nicely into 500, I would simply leave it as this wonderful fraction, centimeters cubed, because it's volume. And there you go. That's your answer. However, if I wanted you to write this rounded to the nearest whatever, you would multiply 500 by pi and then divide that by 3, meaning you would type this exactly with pi in the calculator, which is 523.6 centimeters, excuse me, centimeters cubed. What you do not want to do is, I don't want you to write this as 166.7 pi. Okay? You're mixing an two, I guess not irrational numbers together, but you're mixing this rounded number with pi. So I either want it as an exact value, which would be this 500 pi over 3. Okay, that's an exact value. Or I want the whole thing as a decimal, which means you're typing in the pi. Okay, cool. So that's the most basic kind of problem you're going to see. Now, you'll also see problems where you have to work backwards and find the radius. So let's look at this next one. Write this down and feel free to pause if I'm going too fast. It's the wonders of videos, right? So find the surface area of a sphere with volume equal to 288 pi. I guess we'll stick in some variables there. Let's do meters cubed. Okay, so we want the surface area of this sphere, which is 4 pi r squared. But all we're given is the volume. So that means we are missing the radius right now. And we have to find it by using the volume formula and working backwards. Does that sound like fun? Siri, I don't need you. Sorry. Okay, working, backwards. Just so you know. Okay, so we're going to take the volume, 288 pi, and we're going to set that equal to the formula for the volume of a sphere, which is 4 pi r cubed over 3. Okay, now whenever we have fractions, we want to try to eliminate those fractions. It's easier to work with if it's not a fraction. So we have to multiply both sides by the denominator. So we're going to be doing 288 multiplied by 3. So it cancels it out on the right hand side. 288 times 3 is 864 pi. And then I'm left with 4 pi r cubed. So we're trying to isolate to r. So we're going to divide both sides. Ooh, wait, I like colors, sorry. Divide both sides by 4. And let's go ahead and divide by the pi as well, because we know we're going to cancel that out eventually. The 4's will cancel out, and 864 divided by pi is going to be 216 is equal to r cubed. Now, normally, if this was r squared, you would say square root it, right? But that's not a square. What is that? That is a cube. So we have to do the opposite of cubing, which is cube rooting. So it looks like this. Let's get another color up in here. How about we'll go to purple. So cube rooting, let me move this, is going to be the same kind of thing as square rooting, but you have to add a little tiny 3. That's called the index there. And what you're doing is you're looking for groups of 3 numbers that are the same, that multiply to give you that number. So we kind of talked a little bit about this a while ago before Unit 6, where we had to simplify the radical, right? But instead of looking for twins breaking out of jail, we're looking for triplets, right? So that's how you would simplify the radical, but before you do, always check to see if it's not a perfect cube or perfect square, in this case perfect cube. So on your calculator, best way to do that is to type in the cube root. So if you have your graphing calculator with you, it's going to be on the left hand side, and I believe you have to type second and then something, I don't know, I don't have one with me so I'm not looking at it, but you type that and there'll be a little 3 right there, okay? Or you might have to put a little 3 right in there, depending on what kind of calculator you have. And then you type 216. And the cube root of 216 is, pretty sure, it is 6. Yes, it is. Right? Yes. Okay. So that cancels out this cube and the cube root, which just gives me the radius there. Okay? Copper. Stop it. I'm making a video. This is very important. Stop. All right. But we're not done, right? We actually wanted to find the surface area. So once we have that, then we take this surface area formula. Okay, and we're just going to plug in the radius. So 4 pi times 6 squared. That is going to be 36. 36 times 4 is going to give me 144. Pi is my answer, and that is meters squared. The radius was meters. Surface area is meters squared. Ta-da! Wasn't that fun? Yes, working backwards is so much fun. A nice fun puzzle. Okay, so good? We're good with that? Okay, I have one more example for you. But I'm going to pause this video because sometimes if they're too long, I don't like to... No, I think we can finish it. If not, I'll just cut the video. Okay, so this one I wanted to show you because I saw a couple of problems on your homework where you had what's called a composite figure. Composite figure is when you combine two figures together, create this other fun figure. So you should have noticed this on your quiz.